guys, sorry I am not here today. I had to go out of town, so unfortunately you have to learn from watching a YouTube clip of me teaching. But you have a great sub here, so be good, and hopefully I can explain all this to you and so you totally get it. So today we're going to do space figures and nets. So we're going to start talking about polyhedrons. And a polyhedron is a three-dimensional figure whose surfaces are polygons. So faces would be like the top and the bottom and the front and the back and the left and the right. The faces on this would be rectangles. The edges is each side where the faces come together to make one. And then the vertices is each point. So in this picture, there are 6 faces because there's the top, the bottom, the front, the back, the left, the right. There are actually 12 edges. So like this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then the vertices is each corner. So that would be 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 vertices. Okay. So you're going to have some problems where you have to decide whether this net folds up to make a cube. So if I'm looking at this net, I would fold up the D and the B, and then this A would fold over the top, and then I would fold up the F and the E, and then I would make a cube. So this does fold into a cube. The opposite faces would be A and C, B and E, and D and F whenever you fold it up. F would fold over the top, which would be opposite D. It seems like the opposite faces are always like, it skips a section. So like A and C are opposite, B and E are opposite, and D and F are opposite. So you're going to have some problems on your assignment where you have to decide whether or not those will fold up to a cube. So like on this one, if I were to fold it up, the E and C would be opposite. D could stay on bottom, and B would fold up over D, and then the A and the F would be opposite faces. So this would be yes, it would fold into a cube, and the opposite faces would be E and C, D and B, and then A and F. This right here, there's no way to make it into a cube. If I fold this up, then I've got 2 sections there, and then I try to fold this over, and there's no way it would make a cube. So this would just be no. So you're going to have some questions where you have to decide whether or not that would fold into a cube. Okay, these are Platonic solids, and these are pretty important. You might see these on the EOI test. This is a tetrahedron. It's made up of all triangles. This is a cube. But another name for a cube is a hexahedron, and that has been on the EOI test before, so make sure you know that another name for a cube is a hexahedron. That's also on your test on Friday. Another name for a tetrahedron is a triangular pyramid. We also have an octahedron. It's made up of 8 triangles, octagon, 8 sides, so 8 triangles, and there are 8 faces. There's an isosahedron, which is 20 faces, and they're all triangles. And then the dodecahedron, all the faces are pentagons, and there are 12 faces. You're going to have a problem where you have to match up the net with the figure. So this is what a net of a cube or a hexahedron looks like. This is a net of a tetrahedron or a triangular pyramid. This is a net of an octahedron. This is a net of an isosahedron, and this is the net of the dodecahedron. So you're going to have to match those up on your worksheet today. You're going to have some problems where you have a picture and you have to try to unfold it and make a net. So this is a graham cracker box. So I always imagine starting with the bottom, and then I imagine unfolding each piece. So if this is the bottom of my box, I would fold off this piece and the front and the back. But then don't forget about the top of the box too. So we're going to match our nets. So this is a cube, also known as a hexahedron. That's on your test. So that would match up to C. This one, which one do you think that would match up to? Have you figured it out? It would match up to D. Which one do you think this one would match up to? That would match up to B. And then finally, the last one matches up to A. So I hope you're doing okay on those. Okay, you're going to have some problems where you actually have to draw the net. So like I said, I like to start at the bottom. So I'm going to start at this bottom piece right here. And then imagine unfolding each triangle face. So I would unfold the back, the side, the front, and the other side. And that's my answer. Again, on this one, I would start at the bottom. Imagine unfolding each flap. So I've got this side, this side, this side, and this side. But don't forget about the top. You can add that onto any side. It doesn't matter. I'll just add it on right here. On this one, I've started at the bottom, so that's a hexagon shape. So I'm going to start with my hexagon shape. And then I imagine unfolding each section. So I've got this section, this section. It looks kind of like a pretty flower. And then we can't forget about the top. So you can add it onto any piece. It doesn't matter which one. I'll add it on here. And that would be my net of this figure. Okay. You're going to have some problems where you have to use Eulers' formula to find the number of faces or vertices or edges. It looks like Euler, but it's pronounced Euler. So Euler's formula says if you take the faces plus the vertices of a three-dimensional figure, that always equals the edges plus 2. So here's an example. It says use Euler's formula to find the number of edges of a polyhedron with 6 faces and 8 vertices. So I'm going to plug in 6 for faces, 8 for vertices, and that always equals the edges plus 2. So 6 plus 8 is 14, equals edges plus 2. If you minus 2 on both sides, you get 12 as the number of edges. So let's try some. So we always have to remember Euler's formula. Faces plus vertices equal edges plus 2. So on this one, my faces is 5. Okay, sorry about that. Back to it. Okay, so I have 5 faces and 5 vertices. I need to find the number of edges. So I'm just going to plug everything in. So I've got 5 for faces plus 5 for vertices equals edges plus 2. 5 plus 5 is 10 equals E plus 2 minus 2 on both sides. Our edges is 8. Okay, let's try another one. This time I have to find the faces. I don't know how many faces. So I know I have edges is 9, 6 is vertices, so I'm going to plug it in. So faces plus vertices, which is 6, equals edges, which is 9 plus 2. So faces plus vertices equals 9 plus 2 is 11, minus 6 on both sides, and faces would be 5. Okay, let's try this one. I've got faces and edges this time. I need to figure out vertices. So I'm going to just plug in 8 for faces. So 8 plus V, since I don't know my vertices, equals edges, which is 18 plus 2. So I've got 8 plus V equals 18 plus 2 is 20, minus 8 on both sides. Vertices is 12. So I hope you understand that. The next ones are a little bit harder. So let's see if we can do these next ones. Okay, so this one, we have to figure stuff out. So that's what makes it a little bit harder. I might need a calculator for these. Let's see. Okay, a polyhedron that has 2 hexagon and 6 rectangular faces. So we have a total of 8 faces. So we're still going to do faces plus vertices equal edges plus 2. So I've got my faces, and I have to find the vertices. So what I'm going to have to figure out is how many edges I have. So I already know I have 8 faces. So 8 plus B equals. Now I have to figure out how many edges I have. Well, if I have 2 hexagon faces, how many sides is a hexagon? It's 6. So if I have 2 hexagon faces, 2 times 6 would be 12 total edges. Then if I have 6 rectangle faces, how many sides is a rectangle? So a rectangle is 4. So if there are 6 of those, 6 times 4 is 24. So the total number of edges would be 36. However, if you build a polyhedron, when 2 edges come together, it makes 1 edge. So I have to take that 36 and divide it by 2, and then that's going to give me my number of edges. Okay, back to it. Sorry about that. So 36 divided by 2 would be 18. So I've got 18 edges plus 2. So 8 plus vertices equals 18 plus 2 is 20 minus 8 on both sides. So vertices would be 12. Okay, those are kind of hard. Let's try another one. This one I have a polyhedron with 8 triangle faces. So we know there's 8 faces again. So I'm going to do 8 plus v. Now I can figure out the number of edges. So if there are 8 triangle faces, how many sides is a triangle? Well, there's 3 sides in a triangle. So 8 times 3 is 24. But remember, in a polyhedron, when 2 edges come together, they make 1 edge. So you have to take that 24 and divide it by 2. So if I divide by 2, I get 12 edges. So I'm going to plug 12 in here, 12 plus 2. Because it's faces plus vertices equal edges plus 2. So I have 8 plus v equals 14, because 12 plus 2 is 14, minus 8 on both sides. So what's 14 minus 8 would be 6. So the vertices is 6. Okay, one more. So I have a polyhedron with 1 rectangle face and 4 triangle faces. So 1 rectangle face. Well, how many total faces do I have? 1 rectangle, 4 triangles makes 5 faces. So 5 plus v equals. Now we got to figure out our edges. So 1 rectangle. How many sides is a rectangle? Well, rectangle's 4 sides and we only have 1. And then I have 4 triangle faces. Well, how many sides is a triangle? Well, there's 3. So 4 times 3 is 12. We have to add those 2 numbers together to get our total edges. So I would have 16 edges. But remember, in a polyhedron, when 2 edges come together, they form 1 edge. So if I divide this by 2, I'll get the number of edges. 16 divided by 2 is 8. Plus 2 to finish my formula, because it's faces plus vertices equal edges plus 2. So 5 plus v equals 10, minus 5 on both sides. Vertices is 5. So those are the hardest out of all the problems that you're going to have today. Okay, so I got a few jokes. You know me and my jokes. So this first one, the cat is talking, and the cat's like, "This is a killer app." And the app's name is Curiosity, because you know how Curiosity killed the cat. It's funny. And then this one's kind of funny too. So we got this pig laying out in the sun, and he looks at his friend and he's like, "Maybe next time you use a little sunscreen." So the pig turned into bacon. Yum. Okay. Got one more. I thought this was funny. So this is Pythagoras in his teenage years. So he says a squared plus b squared equals your mom. Ha ha, funny. Okay, your assignment today will look like this. So on the first 3, you have to decide yes or no if it's if it can fold into a cube. If it's yes, tell me the faces that'll appear on opposite sides. On 4, 5, and 6, you're actually going to draw the net. So remember to start with the bottom and then imagine unfolding each piece. On 7, 8, and 9, you're going to match the picture with the net that's already there. So that's just matching. Then you start your faces plus vertices equal edges plus 2. So you'll plug in the information that you have and then solve for the missing piece. And these were also on the notes. This is the Platonic solids, and you're going to match the Platonic solids to their net. So that is the first part. Part B says the first two Platonic solids have more familiar names. So I hope you remember the two names for a tetrahedron and a hexahedron, what the other names are. I think that's it. I hope you guys have a good day.